one of the effects, if I understand correctly, that we expected to see and are seeing from more open water in the Arctic is that during the wintertime, more snow in places like Siberia.
Hmm.
At the same time, uh, um, we're seeing less snow during spring months. So can
Right.
you just kind of balance that out for us?
Right. So what we think is happening in the fall is that because, as you say, we have more open water in the fall as the sea ice gets smaller and smaller, that provides a source of moisture for snow to occur. And you can think of it like the lake effect snows that we have downwind of the Great Lakes here in the fall. You've got this warm water, it's relatively warm, it's evaporating a lot of moisture into the atmosphere. So when you get a wind blowing from that water onshore, just like in the Great Lakes situation, it brings that moisture onshore and it creates a lot of snowfall on the coastline of wherever that wind pattern happens to be set up. Um, it's been happening fairly persistently and regularly along the north coasts of Eurasia in particular. And what we think is happening as a result of that is once you've got the snow falling there earlier and deeper than it used to, it allows the surface to cool faster. And that cooling of the surface has actually changed the jet stream also. It makes that gradient in temperature, that north-south difference in temperature, shift southward. And that allows the Arctic air to penetrate farther south into Eurasia. And we believe that's helping to lead to the colder winters that have been experienced in Central Eurasia, China, and even in Europe. And there have been some recent papers that have been documenting this. So in the springtime, then, a very different situation is occurring. And what we're finding is that the probably just related to the warmer atmosphere in general, and possibly also more cloudiness and this additional moisture in the atmosphere I mentioned, the snow is melting earlier in the northern parts of the northern hemisphere continents. So when that happens, that snow this past year during both June and July just completely smashed the records from previous years. It's been a very steady decline through the spring months. And as that snow recedes earlier, it exposes the soil underneath earlier to that very strong spring sunshine, which allows it to dry out earlier, which then allows it to warm up earlier. And there have been some recent studies suggesting that this phenomenon happening in Eurasia has contributed to the droughts and heat waves in Russia and in Europe in recent years. And it could also have contributed to the drought that we've had in the last 2 summers in North America as well.
So we're losing a spring snow cover in the
Rapidly.
north more rapidly than we're losing Arctic ice.
Exactly. The percentage loss is larger than it is for the sea ice.
Okay. So looking forward, do you have some new papers coming out, I presume? And
Well, I've been so busy talking, I haven't had a lot of time to sit down and write, but we are going to be working on some new papers, I hope, in the next few months. Um, yeah.
okay, and what I talked to Jeff Masters not long ago, and he said we've had back-to-back years of this weather whiplash,
Right.
and just by the law of averages, maybe we should see a year or two where things get a little bit normal. But so far this year, not so much. What do you see going forward?
Well, I don't see any good physical reason why we should recover from a weather whiplash scenario. I mean, it's all related to this idea that the jet stream is becoming wavier. Those waves are what are responsible for this weather whiplash. When you get big waves in the jet stream, that's when you get weather whiplash because it allows the cold air to penetrate farther south when you get a big dip in the jet stream, and it allows the warm air to penetrate farther north when you get a big ridge in the jet stream. And so when you have these two side by side, which is pretty much always the case when you have a very wavy jet stream, then when that wave passes you, you go from one extreme to the next. And so as long as we keep losing the sea ice and the Arctic amplification is continuing to increase, it doesn't make much sense to me that we should return to a more normal condition. I think we'll probably see this kind of scenario becoming more normal rather than less normal.
So welcome to the rest of our lives.
I think that's the way things are. I mean, what could happen is we could have a very strong El Nino, for example, that would maybe overwhelm the signal that the Arctic is imposing onto the large-scale circulation, or a La Nina, or some other natural large-scale phenomenon. And the interaction between those natural oscillations and patterns in the atmosphere and this sort of new kid on the block, the new Arctic amplification signal, how those things interact, I think are going to be a very hot topic of research in the next few years.
Okay. All right, Jennifer Francis, thank you so much for your time.
You're very welcome.
And for
nice
your
to
research.
See you.
Yes, you are one of the best, you're one of our most valuable players in science communication right now. And,
oh, thanks for that. I appreciate that very much.